Hello, everybody. Welcome to my presentation. I'll be talking about performance and how you can optimize your performance of your WordPress plugin. I'm going to talk about WordPress plugins because that's my job essentially, but everything I say can be applied for website developers as well. Hi, I'm Leonidas Milosis. I'm a plugin developer at Yoast. I'm based in Thessaloniki, and I have more than a decade of experience with the WordPress ecosystem. I'm passionate about backend performance, and I'm grateful that I can work for that on products that reach millions of users worldwide. So first of all, why should we even care about performance? Why should we even bother optimizing for it? According to the Mozilla Foundation, web performance and its associated best practices are vital for your website visitors to have a good experience. And what does good experience mean? Basically, it means better conversion rates. Some anecdotal numbers. According to Amazon, every 100 milliseconds of latency cost Amazon 1% of their sales. And in a similar fashion, according to Walmart, speeding up pages by 100 milliseconds affects their incremental revenue by up to 1%. According to Financial Times, 1 second delay in page speed leads to 4.6 drop in article views. So we can understand that no matter the industry, having a fast site, have a performance site, basically means more money. But even if you don't care about the conversion rates, even if you don't sell anything online, you do want to be discoverable. So good user experience also leads to better SEO. Google's core ranking systems look to reward content that provides a good page experience. And that's coming from Google itself. So Google, they highly recommend site owners achieve good core web vitals for success with search and to ensure a great user experience generally. This, along with other page experience aspects, align with what their core ranking systems seek to reward. Core web vitals, there are some metrics. The largest contentful paint that measures loading performance, the interaction to next paint that measures responsiveness, and the cumulative layout shift that measures visual stability. Most of my talk will show ways to impact the LCP metric, the largest contentful paint, so you can have that in mind going forward. So from that, we can understand that good performance is an asset and bad performance is a liability. Performance in general is a feature. It's something that you always have to work for, something that never ends. No matter what stage your project is, you should always look for good performance. So I couldn't really cover everything in 30 minutes, but I thought I could give a couple of examples of quick wins for performance. And so yeah, we can talk about that and see how you can easily have impact on the performance of your plugin by doing a couple of simple things. First of all, you can search your code, you can search your plugin, your website for cacheable database operations. Basically, are there queries that we can cache? Which leads me to mention the WordPress object cache. Has anyone here never heard of this class provided by the WordPress core? So everybody has heard of it? Nope? All right. So a quick introduction. The WordPress object cache is used to save trips to the database. The whole point of having cache is to save trips to the database. Going to the database is something expensive in general, something that takes time, and something that if we can avoid, we want to do that. It stores all the cache data to memory and makes the cache contents available by using a key, which is used to name and later retrieve the cache contents. By default, the object cache is non-persistent, which means that data that's stored in the cache resides in memory only, and only for the duration of a page request. Cached data will not be stored persistently across page loads unless you install a persistent caching plugin. And speaking of persistent caching plugins, some mentions here. The Redis Object Cache plugin provides a persistent backend for the WordPress object cache. The downside, you could say that you have to have an external Redis server. If you don't want to go through the hassle of having an external server, you can use the Docket Cache plugin and the SQLite Object Cache plugin. I'm mentioning these plugins because persistent object cache is something that can have great impact on the performance of a website. So about the WordPress Object Cache class. I'm going to mention a couple of main functions that it provides that we can use. I will later provide an example on how you can use those. We have the WordPress cache get function that retrieves the cache content from the cache by key and group. We have WordPress cache set that saves the data to the cache, and those two are your main functions, the ones you use to read and write data from cache. You have WordPress cache delete that removes the cache content matching key and group, and WordPress cache flash group that removes all cache items in a group if the object cache implementation supports it. So these two functions are the ones we use to invalidate cache, and I'm going to mention why is that important. So a question that that we can answer, that we can ask ourselves to have a quick win in performance, is to identify queries in your plugin that you can cache or you should cache. So those questions that you have to ask yourself are: should I cache that query? When should I do that? Basically, you should consider caching a query when it's computationally expensive. Maybe it's on large tables, maybe it's a nested query. And then, if that's true, you have to consider if it's clear when to invalidate cache. You have to invalidate cache in proper spots in time to avoid serving stale data. A tool you can use to answer those questions is the popular Query Monitor plugin. This is something we use at Yoast normally when we develop our features. It's something that gives you a great overview of which queries are being run in a page load in order for that page to be rendered. You can see here, if you are an admin and you visit any page of your website, you see an overview of the queries, of the number of the queries at the admin top bar. And at the bottom of your screen, you see the list of the queries, who is calling them, how much time they need to be run, etc. So using that Query Monitor plugin, you can search for queries in your plugin that you want to consider to cache. I want to lay a real-world example here so you can understand what I'm talking about. So here in Yoast, in the Yoast SEO plugin, we have a feature called orphan content. In SEO terms, your website should not have orphan content, which basically means you should not have parts of your site that have no incoming links to them, because those posts, those pages are separated from the rest of your website, and Google is not really able to crawl it very efficiently. So we want, the Yoast plugin wants to give an overview to site owners to see easily which post is orphaned, so which post has no incoming links to it, and we give them the respective filter. But in order for that filter to work, we need to run a pretty expensive query, unfortunately. And that's something we can't really work around. So when you're on the posts overview page, we show that we have a query that is a bit complex, that takes a lot of time to be run. So this makes it hard for our users to go into that page, because if that site had even more posts, that number would be even bigger. So we understood that this was something that we should consider cache. We should consider add a layer of cache around it, so we don't have to go to the database every time this page is loaded. So we decided to cache that. I'm going to share some code here, but without any context, the getPostTotal is the function responsible for coming up with that 733 number. So that function runs this query, the complex query that we want to cache, and it returns the result. So what we wanted to do, we wanted to add the cache layer around that. So what we did, before the query, we started trying to get the cache. You can see we assigned the WordPress cache get result to the count variable, and if there's no cache first, that count will be false, and only then we will go into the if and we will run that query. But next, as soon as we get that result, that count number, we go and use it in the WordPress cache set function, and that way, after the query has run for the first time, we have a number that we can cache. So the next time this function runs, the count at the top of your screen, the WordPress cache get will actually have a number. The count will not be false, so if we will not get into the if, we will not run that query again. I mentioned before about cache invalidation and avoiding serving stale data. So this is equally important to actually saving cache and reading cache. For this example, I said before that this number represents the amount of posts that have no incoming links to them, no other posts pointing to them. So we understand that every time this number changes, we need to invalidate the cache so we don't show users wrong numbers. We have, fortunately, we have a dedicated function for that. We call posts in our code base indexables. So we have a function called update incoming links for related indexables. So this is the exact point in time that we want to invalidate the cache. So every time this function runs, we check if the object cache implementation supports the flash group function, and if it does, we actually go and flash the orphan count cache. So all that to say that in this page, the first time it runs, we will have to run the query that I show you, but the next time, until the cache is flashed, we will not have to run that query again. So that way we save the query. We saved, I showed before, it took like 0.0018 seconds, but in larger sites it could be bigger. So that way we gained just a little bit of performance for the users that have Yoast SEO and visit the post overview page. So that's how you can identify database operations that you can cache. And that was my first point of having a quick win for performance. The next one is looking into recurring operations. Basically operations that run very often on your plugin, on your website, and ask ourselves, can we optimize code that runs that often? Because even the tiniest benefit will get added up and actually have maybe greater impact on your plugin. So for example, we have some code here that runs very often in the Yoast SEO plugin. It basically compares two arrays to see if they are the same. It runs pretty frequently. It runs actually on every page load. And if it's not optimized, since it runs so frequently, its effects are compounded. So we wanted to be sure that this is as fast as it gets when we want to compare two arrays. And we asked ourselves, what if a simple strict comparison of arrays is faster instead of this whole big if? So the question became choosing between those two approaches. The first one first checks the size of the two arrays and then calculates the diff of the one versus the other and then the other versus the first one. And only then it understands whether the two arrays are the same. And the second approach that we want to see if it's faster was actually basically doing a simple strict comparison of the arrays. And since AI is all is all about, we had a previous talk about it, we wanted to actually use AI to optimize that. It's something that even junior developers can do, even if they don't feel confident in refactoring code for performance, even if they don't know where to start. AI gives you great starting point to do that. So in our workflows, we use Copilot, the Copilot agent. So we use that to see if we can optimize that code. What we did was to select the code, the candidate code to be optimized. We added the selection to the Copilot chat, and we asked Copilot, I want to understand whether this way of checking if two arrays are equal is the most performant one, and specifically if it's more performant of just comparing the two arrays with a strict comparison. And Copilot responded and basically said that yes, the second approach is faster. For small arrays, it's not really, there's not really a difference, but for larger arrays, the strict comparison is faster because it does not need to loop through and compare values individually. It just checks the structure of the arrays. It also added some additional information about the comparison, saying that the strict comparison is not suitable if you want to treat arrays with the same values in different orders as equal. Fortunately, that was not the case for us. So basically, Copilot said that yes, you have to refactor that code if you want to optimize for performance. But like we all know, we shouldn't trust AI blindly. You have to cross-reference what it says to you. So we wanted to use AI to check AI, basically. So we asked Copilot again, continuing on that, I know that the two arrays are maximum of 100 elements. Can you create a benchmarking script that compares the two approaches? That script should give me the average calculation time for both approaches in a sample size that's large and diverse enough to give safe conclusions. So we directly instructed Copilot to help us understand whether he was true or not before. So Copilot came up with a snippet, with a benchmarking script. And we took that and we ran the snippet in the 3v4l.org website. I don't know if you heard of this site. Really useful. It allows you to run PHP snippets in multiple PHP versions simultaneously. Yeah, very useful. So the benchmarking script took both approaches, the original one and the optimized one. It created a big enough sample, and it randomly made some arrays different in that sample, and basically ran the two approaches, I think it was 10,000 times, and it came up with the average time for both approaches. The result was actually pretty astonishing. The average time for the first approach was 30 microseconds, And for the second one was 0.13 microseconds, so several orders of magnitude faster for the second approach. So that gives us the confidence to understand that the Copilot was right. But since that code is running really often, we wanted to be absolutely sure that what we were about to do was right, and if we haven't missed anything, basically. So we went back to see the code that we were about to replace. Like I said before, the code first checks if two arrays are of equal size, which means that if they're not, they will not, the code will not even go and check the other conditions, so it will return early. So we have to understand that maybe we have to diversify our sample a little bit more and make sure that we add a couple of cases where the arrays are of different size, because that was an actual case in our code. So we went back to Copilot and we said, can you adjust the benchmarking script to also sometimes compare between arrays with different sizes? Copilot gave us a new snippet, and it randomly decided if arrays should be the same size or not. And we ran the snippet again, and the results were again proving that this tree comparison approach still was pretty faster than the first one. So we are even more confident about the optimization. At this point, we were confident enough, and we actually did the refactoring, so we shipped that change. And since that code was running pretty often, we actually saw some impact throughout our user base. So this is the second example of a quick win that you can have in performance. Like I said before, this journey never ends. Trying for performance never ends. You will have regressions in the performance of your software, that being the plugin or a website or whatever. You need to measure that, you need to strive for that, you need to treat it as a feature, like I said. I hope I gave a couple of examples of where you can start. But if you want to know more, you can come find me, talk to me about performance. I can talk about it every day. So, yeah, thank you very much.
Thank you, Leonidas. This is Sparta. Any questions? No? You definitely have questions. Ή ερωτήσεις άμα θέλετε. Εντάξει, δεν θα πάθουμε και τίποτα.
Απαντάει και στα ελληνικά.
Απαντάει και στα ελληνικά. Απ' όλα έχει ο Μπάξες.
Λεωνίδα, σε ευχαριστούμε για την καταπληκτική παρουσίαση. Ήθελα να ρωτήσω, υπάρχει περίπτωση να κάνουμε too much caching?
Υπάρχει περίπτωση να κάνουμε too much caching. Αυτό είναι μια ερώτηση για website owners κυρίως. Ναι. Όπως σε όλα τα πράγματα, πάνε με τον άριστον. Αναλόγως στο use case, αναλόγως στο traffic σου, αναλόγως στα data σου, υπάρχει πάρα πολύ μεγάλη προσπάθεια που μπαίνει σε αυτό. Δεν είναι ναι ή όχι. Κάθε περίπτωση είναι διαφορετική, οπότε πρέπει να βλέπεις κάθε περίπτωση διαφορετικά. Υπάρχει πιθανότητα να κάνεις too much caching και δεν είναι ποτέ η απάντηση σε όλα. Πάντα πρέπει να σκέφτεσαι και να βλέπεις τον κώδικά σου, να βλέπεις τα κενά του, να βλέπεις τα inefficiencies του κώδικα, και αν δεις ότι είναι όσο πιο optimized μπορεί να είναι, τότε μπορείς να σκεφτείς για το caching και για όλα τα υπόλοιπα.
Υπάρχει κάποιο κριτήριο που να πεις ότι αυτό δεν το κάνω caching, γιατί γι' αυτό και γι' αυτό το λόγο, δηλαδή...
Αναλόγως και για τι caching μιλάμε. Υπάρχουν κριτήρια όπως όταν κερδίζεις κάτι, πάντα χάνεις κάτι. Όταν κάνεις cache, είπαμε ότι σώζεις δεδομένα στη μνήμη. Αντί για να πας στην database, πηγαίνεις στη μνήμη. Αυτή η μνήμη, για παράδειγμα, πρέπει να μείνει μέχρι κάποιο συγκεκριμένο μέγεθος. Δεν μπορείς να αποθηκεύεις τα πάντα εκεί, γιατί κάποια στιγμή θα δεις deficiencies από αυτό. Οπότε πάντα πρέπει να έχεις μια ισορροπία την οποία πρέπει να κρατάς. Πολύ θεωρητική απάντηση σε μια αρκετά θεωρητική ερώτηση.
Αυτά τα ρημάδα, τα transients που έχω δει εκεί πέρα, κάποιοι τα χρησιμοποιούν, τι φάση είναι καλή?
Καλή είναι, αρκεί να ξέρεις. Είναι άλλο ένα παράδειγμα persistent cache, τα transit.
Σας βλέπω... Τα κατέχετε τα... Πώς είναι εδώ πέρα developers, ας το πούμε, προγραμματιστές? Κάτι γίνεται. Πόσοι είναι απ' τα άλλα, marketeers, content writers?
Συγγνώμη γι' αυτό.
Όχι, δεν είναι συγγνώμη, γιατί μπαίνουν στον πλανήτη, είναι ένα πέρα οικοσύστημα, είμαστε ολόκληρο. Απλά είναι καλό να ξέρει το κοινό. Κάποια άλλη ερώτηση, ο Λεωνίδας θα είναι εδώ πέρα, δεν θα φύγει. Οι παρουσιάσεις, επαναλαμβάνω, θα ανέβουν online και το βίντεο και η ίδια η παρουσίαση και θα τον βρείτε εδώ απ' έξω. Φοράει και μπλούζα που την καταλαβαίνω. Αυτό είναι για τα ταξίδια σου.
Ευχαριστώ πολύ.
Αλλά έχουμε μια ερώτηση. Δεν θα φύγεις έτσι.
Μιας και έγινε αναφορά σε AI, ποιο μοντέλο συνιστάς να χρησιμοποιούμε μες στο Copilot?
Εμείς χρησιμοποιούμε και το Cloud, χρησιμοποιούμε και το Gemini. Δεν έχω απάντηση, γιατί σήμερα μπορεί να είναι σωστή και αύριο να είναι λαθασμένη. Και το τελευταίο μοντέλο του GPT χρησιμοποιούμε. Συγκεκριμένα το Copilot χρησιμοποιούμε GPT.
Ευχαριστούμε. Ευχαριστούμε πάρα πολύ.